Hello and welcome to Into the Terminal. Today we're going to be talking about logical volume management. How's it going, Nate?
Oh, it's doing great. Doing great there, Scott. Good old logical volume management. Such an exciting topic.
All right, so the first thing we need to do is figure out if we're using logical volume management. But before that, let me show you some terribleness that I've done to this poor machine. Unfortunately, this machine is 100% full on its slash file system. And we know from experience talking about security that that would be very bad for a lot of reasons.
Yeah.
So Nate, how can we tell that this machine is using logical volume management?
So how can we tell? Well, we can look. I mean, at the minimum, you can look at the fact that it's got dev mapper rel root, right? If you know what you're looking at in that mount statement there, right? That's what that's how you know. However, you can also just do like a VGS, right? Won't that tell us, or VG display even will tell us if there's volume groups present on the system and what their names are and things like that.
Yeah, we'll be getting into some of these commands in a bit, but I liked your first answer, which is dev mapper. So
Yep.
logical volume management, and we'll be getting into this after the transition, is really tying together multiple different devices into a single device, and it does that through device mapping.
Right.
Um, so we've got this full file system, but it's a logical volume based file system. And when we do our VGS to show the volume groups, there's our volume group, the RHEL volume group.
Very creative
And
name.
if we look at that line there, how much free space do we have left on it?
Let's see. So V free, right? That's what we want here. That's 0. There's nothing free. So,
Yeah,
Scott,
so
you've totally ruined the system.
I would have to go through and figure out what my big files were and get rid of them. And no. Because it turns out, if we take a look at the devices attached to this machine, I called up my SAN guy and I said, hey, attach some more disks to my machine.
Now,
And they have attached SDC, SDB, and SDD. So these three devices here are new and unused to this machine.
that's awesome. They're so helpful, those sand guys.
Man, I couldn't live without them. So what we're going to do is we're going to add one of these disks to our volume group, which is then going to add more free space. And then we're going to have to consume that free space for our file system. So there's a few steps that we have to do. First, we need to take one of these unused disks, and we're going to use SDB as in Bravo, and we're going to pvcreate it. And what we did there was we just created a small bit of information that will allow us to populate logical volume information onto this disk device. So we know what volume group it belongs to and how much is used and all kinds of stuff.
Right. Because you can't
So
just put
now
a raw block device into a VG. It needs to be a PV first.
yeah,
Basically
and we'll
like
actually take
prepping.
it,
Yeah.
and we'll take a look at what we've done there and the information stored after the transition. So now we've got our physical volume created. We're going to take a physical volume and add it to our volume group. So we're going to extend our volume group, the RHEL volume group, to include dev SDB. So now we slurped up that extra disk space from that additional disk. And if I do a VGS like we did before, right now we've got some free space, about a gig.
Yay. So that's it. We're done,
All right.
right?
Oh, we're not done. Because if we
We're
look at
not done.
our, yeah, we're not done. Because see, we've not allocated that space to our logical volume, which is the root logical volume on the RHEL volume group. So there's another command called lvextend. So we vgextended to add more disk to our volume group, And then we're going to lvextend to add some more disk space to our logical volume. And I'm going to, cheat a little bit since I wrote this down in advance, make sure my syntax is right. I'm going to add 500 megabytes to dev rel root. Okay, so we were able to grow it.
So we added a gig worth of raw disk, but you've only added 500 meg, right? And I assume we're going to talk about this more later, but just note that, folks, that you don't have to use all available space just because it's there. You can leave some around for additional growth later if you really wanted to.
Yeah, or other file systems or a whole bunch of other uses.
Right.
All right, so now if I do a LVs, I show that my root file system, my root logical volume is 17.5 gig. It was 17 gig before. So I got that extra 500 megs.
All right.
But if I look here, it's still not showing up in my available disk space. What did I forget, Nate?
We're still not done. Oh, wait. So on your disk, there's a file system, right? The file system doesn't yet know that the disk is larger. How do we fix that, Scott?
Yeah, so we like added this disk space to our device, but the file system hasn't been formatted across that newly allocated space.
Right.
So we're going to use XFS, growfs on dev rel root. Okay, now before I hit enter on this command, Nate, at this point, can I undo the space that I added and put it somewhere else?
Yeah, so that all depends on your file system. With XFS, you cannot. With
Well, right now,
oh, sorry, before you grow it.
Yeah.
Before you grow it, you could undo it. After you grow it, you cannot.
Correct. So some file systems allow you to shrink the file system as well. XFS is not one of those. So the reason I do it in two separate steps is because I want to make sure that I want to be able to have an inspection point to make sure that my logical volume is the right size. That's my now new expected size. And then once all the disk space looks right, then I can go ahead and push this file system format out across it. Because once I push the file system format out across that newly allocated free space, I can't pull it back again.
Right.
And
now
that's
XFS being the default file system for RHEL. This is definitely a caveat you're going to want to think of. You can choose ext4, I think, still, which can shrink. But usually, if you're just using the defaults, you're going to be on XFS.
That's correct. And the reason that's important is you will recall that we did things like this. We specified an amount of space. And if you typoed that space and you added 5 gig by accident by putting in an extra zero, before you put the file system across it, you could claw that back and reallocate it the right size that you wanted. But as soon as you push that file system across, that's it. It's now part of this file system. There actually is an option for lvextend that will automatically not only extend the logical volume, the amount that you told it, but resize the file system too. So it doesn't have to be two steps. But the reason I like doing it in two separate steps is because I can make sure everything is fine before I go to that irreversible growing of the file system.
Right.
All right. So here we go. Dev mapper rel root right there.
All right. Now we've got 572 meg free.
Yep. Was 72 or 76 meg. Now it's 572 meg. So yay. More space.
You've saved the day, Scott.
Well, I'm an experienced administrator. Stay with us after the transition as we get a little bit more deep into logical volume management. We're going to start off with a conceptual whiteboarding. That should be fun.
Yay, whiteboards.
Make fun of my artistic ability. Where we talk about like what is LVM actually doing? How does it actually work? And then we'll go through some additional commands to work with logical volume management.
All right. All right, welcome back. All right, so that was a fun little dive into LVM. How you doing this morning, Scott? Well, I guess it might be this afternoon for some folks.
Or if they're deferred watching, it might be evening. Who knows?
Could be any
Um,
time of the day.
that's true. The YouTubes are crazy like that.
What is what
I
what
would
is
like
it?
to remind you.
Time appropriate greetings, everybody. How's that?
There you go. This is the area of the program where we take questions from the audience and maybe go off on some audience driven tangents. But also, don't forget to like and subscribe if you want to have more notifications of when we're doing this, or you enjoyed this content, or you can share it with someone that you think would be interested in this too.
Absolutely.
All right, so my whiteboarding, woof, man. All right,
It's beautiful.
yeah, yeah. So these are my disks, right? I got that really big dev SDA2. That was my root file system in the beginning. And then I extended my volume group to also include dev SDB. And we put some space there too. And then I still have these two extra disks the SAN guys gave me, SDC and SDD. They're currently unused, right? So they're just sitting out there on their own. All right. So if we were to take a look at my machine, there's actually two logical volumes on my volume group. So let's see if I can remember how to do this. 1 second. All right. So when we create a volume group, it chops up this disk space into little allocatable units, and they're called extents. And so the situation that we found ourselves in earlier was that my file system was full because I had consumed all the available extents on dev SDA2. So let me do a little bit of coloring and we'll show that.
Wow, what does the knife do?
It's for my disk clowns.
The inside jokes nobody will ever understand. Wow, you color pretty well, Scott.
I mean, I have children, so it's not my first rodeo,
Got
Nate.
some practice. All right.
All right, so I have two file systems. Or two logical volumes, I should say. And one of them is dev mapper rel swap, and the other one is a lot harder than it looks. Was dev mapper rel dash root. Okay, so that pink one was about 17 gig.
Like 17 something, yeah.
Yeah, and then the other one was like smaller than that. But essentially, I used that whole disk, and there was no additional free space. So what we did was we used vgextend and we grew into this dev SDB. And so as a result, it also got cut up into these little allocatable units. And do you remember, Nate, when we extended the logical volume, how much disk space we used?
We added 500, right? Well, you added a gigabyte, but then extended the logical volume into 500.
Yeah, so this disk right here is 1 gig in size. And so all that disk space that we just added was 1 gig. But when I extended the logical volume, I only extended for 500 megabytes, so roughly half of the disk space here. So
Now, for
essentially,
anyone who's curious, you could also have laid down a partition table on DevSDB. Say it was larger than a gig, and you only wanted to allocate, I don't know, half of it to this particular volume group. You could have made a partition table and allocated the physical volume in a partition, right? So you can slice this up even further if you really wanted to. Say you had more than one volume group on a system, that sort of thing.
yeah. And so this is essentially what we ended up with in the um, at the end of our critical path, where we now have extended our root logical volume to include this additional space from the additional device. There's still some free unallocated disk space on that additional device that we could add to the RHEL root device, or we could add to the swap device, right? We can use it for either of the logical volumes that exist on this volume group.
Or you can make a new logical volume. All of a sudden, say you want temp or whatever. You could make a new logical volume in that free space.
And in fact, why don't we? Well, actually, I think what we're going to do is we're going to create another volume group, and we're going to create a logical volume from scratch in the other volume group. So that's going to be over here in these other two disks. So what we're going to do is we're going to tie these other two disks together. And we're going to create a device file to go along with this disk space, right? To map to this selection disk space. I'll have to look over at my trusty episode guide here to remember what I was calling it and whatnots. Oh, I came up with a really good name.
Is it RHEL 2? No, new. Okay.
Yeah, new vol group.
That's almost as creative as the volume or as the logical volume I made for the disk encryption episode. My vol.
Exactly. So a couple things are going to happen when we create this new volume group. First, we're going to have to prepare the physical volumes to be added. And so what we did originally when we added SDB to our group was we had to put down this little bit of information. So when we use the pvcreate command, what we did was we put down a little bit of information here at the beginning of the disk, and that's called the volume group descriptor area, or VGDA. And it stores information like what volume group does this physical volume belong to? When we cut the physical volume up into smaller pieces, right, the extents, right, so we're going to cut these up into allocatable units. And I need to work on my drawing skills a little bit.
Virtual drawing is always harder than real drawing, I think.
So how big are these little purple blocks of allocatable disk space? That's the extent size. That's stored in the volume group descriptor area. So we put that metadata in there, and then our tools like VGS or PVS will know to look for the physical volumes by their assigned UUID number, also stored in the volume group descriptor area. The volume group itself will have a whole bunch of information that ties these devices together in the dev mapper or device mapper subsystem. All right, so then we're going to go and create a logical volume. And we're going to replace the temp directory on this machine. And looking at my notes, we're going to make a 500 meg temp directory. And each one of these is about 1 gig. So we're going to go in and we're going to do a lvcreate to make a new logical volume to allocate some of these unused disk extents. Running out of colors, Nate.
You've got the whole rainbow at your disposal. You haven't used orange yet. Oh, there, green. Green works.
All right, so we're going to claim those, and then we're going to get a new device file that gets created.
Yep.
Right, we're going to have to use our command line command to tell it like what we want to name it, how big it should be, and things like that. And so when we're doing stuff with dev new vol group temp, the device mapper is going to know that that resolves to this selection of disk extents, right? So that's these green disk extents here. And we'll be able to then expand it, right? Because we have all this unused disk space sitting out here in this other disk that we've not yet consumed anything of, or half of this remaining disk that we've consumed half of. And we can just kind of work with these free bits of disk space. Nate, what would we do if we ran out of all free disk on our machine?
Ran out of all free disk. You mean in the file
Yep.
system or the physical disks?
We used up all the extents, and we didn't have any more free disk space in our volume group.
Well, you'd need to add more disk like we did earlier in the critical path, right?
Yeah, so either you literally add a disk if you're talking about like a physical machine, or you call up your handy dandy SAN people and have them
Yep.
expose the disk to your machine.
Yay,
Or in
sand
this case,
people.
we're actually using virtual machines, so I just like used the virtual machine interface to create an additional virtual disk and attach it to the machine. And then you have to add it to your volume group, and that cuts it up into extents, and then you can grow your file systems into it.
Yep. Yep. Now you've mentioned these extents a bunch of times. Just to be clear on that, that extent size is configurable. It used to be very important because you could only allocate so many to a disk. We had an upper limit of what 65,000. You know, the usual 32-bit integer limitation. With 64-bit systems, that number is so much higher that it's not really an issue. So the extent size can be configured mainly, I would suppose, for performance or disk utilization. But honestly, you can probably just stick with the defaults and never care.
Yeah, and most of the reason is because we had that limit, right, of how many extents we could have in total. Um, that's also an extent is the smallest allocatable unit,
Right.
right? Before we move on, and I'll actually like show you some command liney stuff. Any questions on any of the content we went through here in our overview of how things are kind of working?
So there's been a bunch of conversation from Vladimir in the chat, who's prepping for his Red Hat certification exams, and learning more about LVM has been a challenge. So I'm hoping that all of the theory you've just displayed here has been beneficial. But that's really the most of the conversation. Oh, and how many crayons you have available to you?
Well, and I saw that Vladimir also asked about Stratus and VDO. We're
Yes.
not going to be going into those in this episode. We're already getting pinged by Eric that we're running out of time. So
Yeah.
maybe a future episode we can cover those two, which is Stratus is another way of doing disk pooling beyond the volume group and volume management that we're doing here. And VDO is about deduplication of stored content.
Right.
But we will be covering them in this episode. All right, so let me see if I can change back to my VM. All right, so I said we're going to be creating a new volume group. Maybe.
There we go.
So we need a pvcreate, devsdc, and devsdd. And that puts down that volume group descriptor area. And we can look at that with a PV display
Yep.
on one of those two new devices. So this is the information that's stored in that little blob of space that I colored red in my
Yep.
whiteboarding.
Now, if you wanted to see what PVs were on the system, you could just do PV display with no arguments. It'll show all of them, but that doesn't make it easy for display purposes here. Just information for the viewers.
Yeah, I
Or
actually really
PVS.
like PVS, which is the physical volume summary,
Mm-hmm.
because that'll be a lot less detail than PV display with no arguments, because it gives you like the extended information about all the physical volumes, which will scroll off our screen pretty quickly.
Right.
All right, so looking at this PV's output, you can see that two of our physical volumes are already allocated to a volume group, but our others are not allocated to a volume group.
Indeed.
So we need to create that volume group. And what's our command, Nate?
vgcreate, I think. I know it's really hard to remember the terminologies here. And then
All right,
you
and
just got to tell it what PVs to use, right? And a name.
yes, so you need a name. That's the first argument. So I use the
Right.
very descriptive new vol group, and then the physical volumes that are backing that. All right, and now that we've been allocated to a volume group, if we look at PV display of SDC, right, we see some more information in it, right, because it now
Yeah.
belongs to a volume group. And remember I told you that it cuts up all the disk space into allocatable pieces called extents?
Mm-hmm.
Well, one of those little blocks of disk space that I drew on my diagram, each one represents 4 megabytes of space.
Right.
And so when I say I want, I don't know, 450 megabytes of space for my thing, it'll round up to the nearest whole 4 megabyte piece. So you might end
Right.
up with a 452 megabyte device
Right.
side of it.
And this is where if you make that PE size too large, you could waste disk space, right? If you made it like gigabytes, for example, which would be ridiculous, but for example's sake, right? If you made it way too big, you'd be wasting a bunch of space. Or could be wasting a bunch of space.
Well, you'd be allocating it to your file system, and then you're just making your file systems accidentally larger, right? Because it's going
Right.
to round up
That's what I
to.
mean. You're wasting physical space on the disk.
All right. So now we need to take that space and we need to allocate it to a logical volume. Nate, what's the command to
Okay.
create a logical volume?
Well, vgcreate made us a volume group. Do you think lvcreate makes us a logical volume?
In But you'll notice there's this like theme in all of the logical volume commands. There's PV to
Mm-hmm.
talk about the physical layer of your
Yep.
storage. There's VG to talk about the group where you're like tying those physical layers together, and LV, which is where you're carving out some of that combined disk space into a specific device, which will then format as a file system. But they all have kind of the same syntax. Extending will grow something,
Yep.
creating will make something, and where you want to work in your storage stack determines whether it's a PV create or a VG create or an LV create. All right, so here in LV create, we need to tell it how much disk space we want to consume.
Yep.
Again, it's going to round up to the nearest whole extent size. And we
Yep.
need to
And you
get
could specify this in extents if you wanted to, but it's so much easier to do it in human readable format, which is what the capital L does.
right. Yep. And then give it a name. And then lastly is what disk space, what volume group am I going to consume that disk space from? Because this machine actually has two.
Right.
We have
Right.
the RHEL volume group that we were working with earlier that was created by the installer. And then we have this new one that I made for this example. All right. So now if I do a LVs, these are my logical volumes that are on the machine. And we can see there's my new vol group temp LV. And the last thing I need to do is format it, because right now it's just kind of like a amalgamated device of disk space, but it's been unused, right? So it's raw.
Right. So we've basically gone through all those steps to take an empty physical block device and give us a empty virtual block device.
All right, so I format it, and now I can mount it. All right, so there's nothing in there. But if I look, I can see that indeed it was mounted
Now we
at
have
roughly
10.
500 megabytes, right? So we're looking pretty good.
But did you make it non-executable? Come on, Scott. We just got through the security arc.
Did not. But if I did want it mounted every time we boot the machine, I would want to add
Yeah,
that to the etcfs tab file as well, right?
right.
So you can see that the RHEL swap is in there, and RHEL root's in there. So if I just add my last one,
New vol group. You should have made that a shorter name. New VG would have been so much easier.
there, Nate, just for you.
There you go. Thank you.
All right. So now when I boot the machine, oh, hold on, I have a typo.
Told you should have made that shorter.
What I want. You're
Oh,
not the
you put a
boss.
slash instead of a dash. I get it.
Yeah. You could have also done it this way.
I was just thinking there's also a dev vol group, right? Yeah. You could do it that way if you wanted to.
Yeah. So there's two ways of referring to your volumes, your logical volumes. Dev volume group name and logical volume name, like I have here with temp. Or you can use dev mapper, which we'll also see on a lot of the tools like df. So dev mapper, volume group name, dash logical volume name. Either one of those paths will get you to the same allocation of storage. So you can use them interchangeably.
I'll tell you one little caveat I learned years ago. If you make a volume group or a logical volume that has a dash in the name, then when it goes into dev mapper, it'll have a double dash because the dash is reserved for the separation between the volume group and the LV. I once filled up memory on accident once because of that, because I was trying to write to an LV directly via like DD or something, and I forgot the double dashes.
All right, so
All
we
the
do have,
power that Linux gives you to shoot yourself in the foot.
yeah, well, I mean, it only does what it's told, Nate.
It does. It does.
So we do have one last thing to cover today. I know that we're a little bit long on our episode timing, but the last thing that we wanted to cover today was snapshots. And there's two ways that you can run snapshots. So Nate, you want to tell us about the two different methods of doing snapshotting, and we're only going to show one.
Sure. So there's two ways to snapshot, as Scott suggested. You can snapshot of logical volume in a read-only mode or in a writable mode. And basically the differences there is to which device you'll want to be able to write to afterward, right? So you can make there's a different name for the methodologies here, but essentially what it means is if you take a read-only snapshot, you'll then have a copy of the disk that you can then perform read operations against, right? Which is great for backup, which I think is what Scott wants to demonstrate to us today. The writable one means that the original, you'll make a point in time writable copy of the disk, right? Which is sometimes good if you're trying to try something out and then delete afterward, right?
Yeah, and we use it. There are a lot of other terms to describe that writable one, like an overlay, writable
There,
overlay, something like that,
that's
where
the
you
word I was looking for.
away and you revert it back to like its original state because you threw away all the changes that you persisted in that writable snapshot.
Right.
All right, so I made this file. You might notice it as my important file, and I'm going to surprise you. It's important to me. So
Is
I
it
want to make
important?
sure I pull a backup of it. It's very important. And so one of the problems that we have with backing up file systems just in general is if they're active and there's content being written to them, then when the backup is running and actually capturing the backed up data, um, there's not necessarily a consistent flow of information in the backup, right? Because the underlying file system and file contents might be changing while the backup is running, and that just creates craziness. The other thing is we can use snapshots as like an impromptu temporary space to find files that have changed within a certain period of time or that have been removed within a certain period of time. That's what we're going to do today. So I'm going to create a snapshot. I'm going to name it something very inventive. And I'm going to make it a snapshot of the RHEL root logical volume. All right. Now, a couple of things are going on here in this command. One is I'm creating a new logical volume called backup. So I'm going to actually see dev/rel/backup out there. The other thing is the size. I'm allocating only a certain amount of space to store it. So we will store up to 100 megabytes of file changes that have happened on dev/rel root. But if we go beyond 100 megabytes of file changes on dev/rel root, the snapshot can't hold that change space anymore. And so it does what's called dropping the snapshot, where it just like stops maintaining it. We're not going to run into that today. Oh, and I need, sorry, dash size.
Too few dashes.
Yeah.
There you go.
So really,
Dev backup, dev rel backup. That should work, shouldn't it?
should. This is where the not testing everything out before the show comes to bite us in the rear. All right, so we've got it. It's 100 megabytes. Yeah, it looks about right. You could see in its attributes here, the S in the front tells me it's a snapshot.
Mm-hmm.
And let's, now that we're snapshotting.
Is it perhaps not? No, it sees it, so it is active. I was going to say maybe it created it but didn't activate it.
Well, poo. I'll have to update the comments with what I need to do next in order to mount it. But when I
Should
remove
be
that,
mountable. That's weird.
yeah, when I remove that file from my directory right here, right? See, my important file is no longer there. Before it actually deletes it, it will copy that file's contents into the snapshot, and that consumes some of that 100 megabytes of space. And so as we're making changes to the file system, before things are changed, we're actually writing the original values to the snapshot. And that's where when it runs out of 100 megabytes of space in storing all those changes, it just gives up and stops doing it.
Right.
So you can go into the snapshot and pull out the original values of what was stored in your file system. We could also run our backup software pointing it at dev/rel backup. And even though most of it is being passed through to the live file system because no changes were made to those files, for those files that have been changed, the backup file system or the backup logical volume rather is the source of truth for that, and it gets put into your backup that you're making with your software. But you know what I bet it is? Nope, still no. All right. So I'll have to do a little bit of troubleshooting and write it in the.
It's acting like it doesn't see a file system on it. That's the weird thing. I wonder if there's a special mount command that mounts the snapshot.
I don't recall that being the case, but I'll look it up.
Yeah, neither do I, but yeah.
It.
We could continue to troubleshoot it and continue to eat into the fact that we're over, but trust us, you can mount them afterward. We just have to find the right syntax.
That's right. Again, it's a live demo. What could possibly go wrong when you've not
What
verified
could go wrong?
the show?
What could go wrong? Yeah, Eric's already claiming that I called the bad luck from the pseudo episode, but 95% of the demos today worked perfectly. That's not like the pseudo episode.
All right. So that's where we're going to end it today. I'll make sure to update the comments with what I would need to do to fix my horribly broken example. But join us next time for another Into the Terminal. It's going to be a couple weeks. Next week, we all get the day off for a Red Hat
Yep.
Recharge Day, which is really nice. But next Into the Term, I'm sorry, RHEL Presents, which is on May 17th, is going to be with Mike McGrath, the Vice President of Linux Engineering. So if you want to see what Mike McGrath has to say about the state of Red Hat Enterprise Linux, and oh, by the way, the Fedora people also work for him, come with questions. He's a fantastic guy, and Eric is really proud that he got him. I'm sure he should be, because Mike's fantastic. So don't forget to smash that like and subscribe button, and we'll see you in a couple weeks. Have a great day,
All right.
everyone.
Have a good one, everybody.